found the green function for this one subject to the. So for this one, obviously the two boundary conditions are on one side, and so the choice, this one, the choice is not the same as what we did in class. So you don't use the same formula. In the class, we are using the self-adjoint form. This is not self-adjoint, quite obviously. So 1.7. So d squared psi dt squared plus k d psi t equals to f. Right. So the question asks you to find a green function subject to the boundary conditions psi 0, psi 0, or both 0. And there's not the upper boundary for the domain. So that doesn't matter. So maybe you set to the infinity, and that's okay. So because of that, the function, so you want to g that so g, t, and t prime, right? So the first you want to find the homogeneous solution. So let's find the homogeneous solution first. The homogeneous solution is just basically f is 0. So this is basically this first order, basically d dt, right? d sine dt plus k. The homogeneous solution is like that, right? And k is a constant. Oh, I take it back. Right, that's why I got confused. I forgot this sign. Okay, so right, one is this is 0, right? Right. The one solution is this one. The other solution is simply constant. Now, if psi is a constant, this is 0. The ddt is also 0. Psi is a constant. So either a constant, say c, or but this one is just like c sub 1, right? This one is like c sub 2 e to the minus k times d, right? That would be a solution for this one. Okay. The two solutions for this one, the homogeneous solution, one is a constant, the other is just exponential function. Okay. And so what we need to do is to find a green function in terms of these two. So like to satisfy the boundary condition at here, so the obvious choice this is obvious choice for t less than the t point, because that includes 0, right? So we are considering t from 0 to t is from 0 to infinity, right? So t less than 0 include that part, so you might as well choose both constant to be 0, right? So that would be totally 0, right? And the upper limit is c1 plus C2 e to the minus KT, right? Right, so that do it, and now we do the same thing. Unlike what we did last time, we are not using the symmetric form. So like y1, y2, and right, we're not using that because this is not a self-adjoint form, right? And now impose the boundary condition, impose the continuity condition. T prime equals to T, and that would equals to 0, but because that included 0. For it to be continuous, so C1 plus C2 T minus KT, and equals to 0. Right? So we don't know where. So we have the basic T equals to T prime, right? T equals to T prime or T, because this is a function of, this is a solution for T. Then C sub 1 and C sub 2 can be a function of T prime, right? And so in order that to be 0, then C sub 1, I mean, you need to solve for that, but then we need to find another condition to solve for that, right? The condition will be like, because the green function is that d squared dt squared plus k dt of the green function t prime is delta function t minus t prime, right? So we do the same trick, integrate t dt, because this is a operator in t, integrate t from t prime minus a little bit, t prime plus a little bit, and then do the same thing here, t prime minus a little bit, t prime plus a little bit, right? And the right-hand side is 1. The left-hand side, this term will be 0 because this is a total derivative, so it will be g at upper limit minus the lower limit. Right? Basically, t equals t prime plus epsilon minus t prime minus epsilon, but the epsilon goes to 0, and g is continuous, so that the second term is 0. Now the first term will give you ddt of g t prime plus epsilon t prime minus ddt t prime minus epsilon t prime. Right, just to integrate that first one derivative, I'll become just dg dt, and the upper limit minus the lower limit, right? So that is this one, and now you determine which is which. The first case t is t prime plus epsilon, so t is greater than t prime. So it is this case, right? And when you take the derivative, you only get the minus k c sub 2 e to minus k, and t become t prime. And so the next case must be the other case, right? T equals t prime minus t. So t is less than t prime. So in this case, which is 0, so derivative also 0. So this is So this is this one, and this one is equals to 1. So implied C sub 2 equals to minus 1 over k e to the k. Okay. So now we have two equations, this equation, no, this equation and that equation, right? And C2 is this one. If you substitute this into here, you get minus 1 over k e to the kt prime, but you multiply e to minus kt prime will cancel. So this cancels with that. And that's become minus 1 over k. So it implies C sub 1 equals 1 over k. Okay. Now we have C sub 1 and C sub 2. So G is basically this one and that one. This one is basically this one. Go to both have a 1 over k. And 1 minus e to the k t pi minus t, because you already originally have minus kt. Right? C2 have a kt pi, minus t, and C sub 1 has this 1 over k. Okay, so that should be your g. And combining this, you can write it like a step function. T pi will be k minus e minus t, and that is for t greater than t pi, so theta. Right. So that would be it. But this one you don't use the Wronskian, right? Because there's no and you actually calculate the Wronskian of this two, then that should not be 0. But there are two solutions, right? So if this is your size of 1, this is your size of 2. Wronskian is size of 1, size of 2, so C1, C2 minus KT, right? And then the C1 pi is 0. C2 pi is minus KC2 minus KT, right? It's still not 0, right? Wronskian for these two are independent. You can see that these two are independent. Yeah. Okay, but you don't use that formula with the Wronskian that for the self-adjoint case. With a 2-point boundary condition, this is not a 2-point. This is the boundary condition both are at the same point. Okay, so that should be it. And what else in this question answer? No. And solve this for f equals e to the minus. And that one. Let's continue doing that. So, f. If f is e to the minus t, right? Then you found a solution psi that's given by g t t pi. Okay. This is start from 0 to infinity. 1 minus e, 1 k, t pi minus t, theta, minus t pi. And substitute f minus f t pi, changing t to t pi, and then integrate t pi. Okay, so that would be supposedly the solution. And what we can do is this is only this is 1 with t greater than t pi. If t pi is greater than t, then it will be 0. It means that t pi So you only integrate from 0 to t, right? And then to 0 to t. And you can get rid of that because from t pi is 0 to t, then this is 1. If t pi is greater than t, this will be 0. You can get rid of that, get rid of this one with changing the upper limit. Okay, and so multiplicate out. And the first term just give you your e to the minus t pi. You integrate that, becomes e to the minus t, exactly the same with the minus sign. And then you evaluate t minus t to 0. 0 to t, I mean, but you have a minus sign, so it's evaluated at 0 first, so it's 1 minus e to the minus t. That's the first term, right? That's the first term. The second term is slightly more complicated. You have a exponential factor e to the minus kt that is not included in the integration. Then the t pi is e to the k minus 1 t pi, right? And also it's minus sign. K minus 1 t pi, so you integrate to k minus 1. And then the evaluate at the two limit comes 1 minus e to the k minus 1. Right. Did I get it correct? Right, that's one of okay. Yeah. The lower limit is 1. The upper limit is k minus. This is a part. This you pull out this factor first, pull this factor, and then this is the integral of k minus 1 t pi in k minus 1. Because of minus sign, you flip the sign. 1 minus. No, I this becomes a plus because I use the minus sign to flip the sign. Okay. Well, that's quite a lot of terms, so you can simplify that a little bit. Okay. 1 minus e to the minus t plus 1 over k minus 1. And the two term e to the minus kt. And then this and that combine to e to the minus t. All right, hopefully I got it correct. Is it correct? I don't know. The way to check it is just put it back to the equation. So this is psi. Hopefully that will check out. Psi pi will be you have 1 over k first, and then this one will be minus sign, so e to the minus. So this one minus 1 minus k e to the minus kt plus e to the minus t. I mean, this one and that one actually you can combine it, but anyway, just keep it like that. And then phi double pi. Okay. Again, okay. E to the minus t minus e k squared minus kt minus e. And then you want this plus k times this one, so basically multiply k to here. And add the two. Add the two. You group the k e to the minus t first. E to the minus t. You have a phi double prime plus k, one of psi prime, k phi prime. First, group all the e to the minus t term. You have 1. But this time you have 1 plus 1 over k minus 1. And then minus 1 over k. And minus over k minus 1. That didn't cancel. I mean, so e to the minus t supposedly is a solution, right? E to the minus t is not a solution. E to the minus t is not. It's not a solution. Minus kt is a solution. Okay. Wait a second. There's a k here. There's a minus k. There's a k. Maybe still right. Oh yeah, I still have this term, e to the minus kt. So this is minus k divided by k minus 1. You have k squared divided by k, so you have k divided by k minus 1. But this is a minus sign. This is a plus sign. But these two terms cancel. That's fine. So we only have this term. That's why. And then now you simplify that. Try to simplify that. Yeah. k minus 1. The 4 terms are k minus 1 plus k minus k plus 1 minus 1. Right? K cancel with k. 1 cancel with 1. K minus 1 divided by k minus 1 equals 1. But right, e to the minus t equals e to the minus. Right, so that's the solution. Okay, so that's kind of give you a check that this green function did work, at least for this case. But supposedly for any general function should work, right? Because you construct the green function basically for arbitrary f, because the green function satisfies the delta function equation, which we erase. Anyway, that's how you construct a green function for non-adjoint, right? Non-self-adjoint equation. Okay. That's it. Any more? One more question?